Hello everybody. Tonight we're gonna talk about regression. And we're gonna talk about two types of regression. The first one is simple regression, when we have one variable that we're trying to predict and we're using one variable to base our prediction on. So the variable that we are trying to predict is our outcome variable, and the variable that we're using for that prediction is our predictor. So for example, if we have final GPA, we can use our beginning GPA to predict that final GPA. So in this case, the beginning GPA is going to be the predictor, and the final GPA is going to be our outcome or predicted variable. Whenever we have more variables that we're using for our prediction, we're talking about multiple regression. In multiple regression, we have multiple predictors or variables that we're using to base our prediction on, and one outcome variable. So let's see how we can do the simple regression and multiple regression in SPSS. We're going to focus on simple regression first. So I have a database here of students, and I have different information on them. I have some information for their beginning and final GPA, and also some scores. So I have some beginning reading, math, language, and spelling scores, and these are actually some of their final scores that they received. So let's say I want to use the beginning GPA to predict what their final GPA is going to be. To do that, I'm going to go under Analyze, and I'm going to go down to Regression, and as of right now we're going to talk about linear regression. So here's the window that is going to open up. Dependent variable is also the same as outcome variable or predicted variable. So this is the variable that we're trying to predict. So we said we're going to try to predict the final GPA based on our baseline GPA. So our final GPA needs to go under the independent variable. Under the dependent variable. The independent variables are the ones that are the predictors, or the variables that we're using to predict our outcome variable. So in this case, since we're doing simple regression, we're going to have only one independent variable. In our case, we said we're going to use baseline GPA as our independent variable or our predictor. We're going to move that under the independent field, and all we have to do is just click OK. And here is our model. So the first box that we have to pay attention to is that model summary box. It tells us the correlation between our predictor and our outcome variable. So we have the baseline GPA as our predictor, and the final GPA is our predicted variable. In our case, the correlation between those two is about 0.61, and just like in correlation, R square is the coefficient of determination, or how much shared variability those two variables have. R, when we square, we get R squared, so we have about 37% shared variability, or the variability, about 37% of the variability in the baseline GPA is explained by variability in the final GPA, or vice versa. So this is very similar to what we talked about in correlations. If we go down to the next box, the ANOVA box tells us whether our model that we've created is significant or not. which means are we explaining a significant amount of variability in our outcome variable. So this is the box that we're looking at, our significance level. Any significance that it's less than our setup significance level, which usually is 0.05, tells us that our model, our overall model, is significant or explains a significant amount of variability. The next box is the coefficients box, and this is what is going to tell us our coefficients to create our regression model or regression equation, and tell us whether our individual predictors that we used in our model are significant or not. So here are, under the B unstandardized coefficients, these are the numbers that we're going to use for our equation. So the constant is the same as the y-intercept. So this is the A in our equation. Remember, we had y equals a plus bx. So this is our y-intercept. The next one, the baseline GPA, is our slope, or our B coefficient, 0.55. So if we have to build our equation based on those numbers, we're going to have y hat, or predicted y, is going to equal to 1.14 plus 0.55x. And this is what our equation is going to look like. Now, this box also tells us whether the predictor that we are using is significant. In our case, the baseline GPA is a significant predictor. And it's the last column under significance that tells us that. Anything that it's less than our 0.05 value tells us that this predictor is a significant one. Okay, so now let's try to do multiple regression. And the only difference as of right now is going to be that we're just going to have more predictors. So if I go back to our database and I look at some of the variables, let's try to predict our math score based on the reading score and the number of tutoring sessions the students received, with the logic that if students are good at reading, maybe they're gonna have easier time reading the problems and understanding the problems to do the math correctly. And if they have received more tutoring, maybe that had helped them with developing their math skills. So let's go under Analyze, and we're gonna go down to Regression, and again linear regression. I'm gonna go ahead and reset that because we're gonna use different variables. So we said we're gonna use our final math score, and we were basing our prediction on the students' reading score and also the number of tutoring sessions that they received. If I have more than 2 predictors, all of those are gonna end up here. We can have 3, 4, 5 or more predictors in our equation. And I'm gonna click OK. So now here's our second model. So we have the two predictors, the number of tutoring sessions, and the rating score have about 51% of shared variability with our outcome variable. Our ANOVA table tells us whether our overall model, by including those two predictors, number of tutoring sessions, and the final reading score, is a significant model, whether it explains a significant amount of variability in our outcome variable, which was the final math score. Under the significance, we can see that that is a significant one. So we can continue on and see if our individual predictors are significant. So here's our final reading score, which if we look across, it is a significant predictor for a model. The number of sessions, however, has a significance that is greater than 0.05. So in this case, this particular predictor will not be a significant one. If we want to set up our equation, again, these are the numbers that we're going to look at. We have our y-intercept, we have our b1 and b2 in this case because we have multiple predictors. So what our equation is going to look like is going to be y hat, or y predicted, equals 10.264 plus 0.781x1 plus 0.129x2. And that's how we're going to do our simple regression and multiple regression in SPSS.